It's late at night and the mobs are starting to spawn. As zombies and skeletons walk towards our hero's home, Steve realizes he's going to have to slay some monsters if he wants to sleep tonight. Luckily, Steve knows just what to use for this mission. He opens up his chest and pulls out the shiny iron sword that he crafted the first time he found iron while mining years ago. The memories came back to him as he dug through the chest. But as Steve pulls out the blade, he finds only a dull, rusty, crumbling knife unfit for battle. It seems as though his trusty iron sword has corroded over its years in storage.
"How could this have happened?"
Steve frantically asks.
"Hey Neil, I'ma take it from here." Corrosion or rusting, when specifically iron rusts, occurs whenever a metal is exposed to an oxidizing agent, mainly the oxygen and water within the air. It is a spontaneous reaction, meaning that it will occur on its own when left to its own devices. Let's take a closer look. The process begins with this drop of water on the exposed iron sword. As the bubbles land, both halves of the redox reaction may occur, and so corrosion begins. The edge of the droplet has plenty of oxygen next to it in the air, and so the reduction reaction begins. Oxygen in the air and water in the droplet reduce to form hydroxide, but this reduction reaction could never occur in the atmosphere without a partnering oxidation reaction. This is where the iron sword comes in. As the bubble engulfs the surface of the iron begins to oxidize and forms iron molecules, two ferrous iron ions. This reaction supplies the two electrons necessary for the oxygen and water to form hydroxide, and so the redox reaction is complete. As you could imagine, this oxidation of iron is very bad for Steve. The free-floating iron 2 ions float into the solution that is the water droplet, and to make matters worse, the hydroxide and iron ions in the droplet that were the product of both reactions can now react with each other to form iron 2 hydroxide, which can also oxidize once more to produce iron 3 oxide, also known as rust. These solids float down and precipitate out of the solution to deposit into the sword a noticeable brown-orange color, indicating the erosion of the material it lies on. If only Steve knew of the many ways to combat this corrosion. For starters, Steve could have removed either the components necessary to form the reduction reaction that accompanies the oxidation of iron, oxygen, and water. In the iron is placed or stored alongside a drying agent, moisture would never be able to touch the iron surface and would be unavailable for the reduction reaction with air, thus preventing the oxidation of the iron as well. Common drying agents include calcium chloride and sodium sulfate, as well as the packs you may have seen at the bottom of seaweed packages, which are silica gel. Steve makes a mental note now to remember to cover his chest in sponges to soak up corroding moisture. A surefire way to make sure that the metal is never exposed to corroding elements in the first place is to put a protective seal around the exposed metal. Aside from making this iron sword look like a kick-ass diamond sword, this blue paint serves to shield exposed iron from the air and water that would corrode it. This is why when paint starts to bleed, only the exposed area behind it starts to rust, not the entire object. Alternatively, plastic coatings or grease can also be used to the same effect. If the oxidizing agent cannot physically get into the iron, then no corrosion can occur, which explains why Steve's minecart wheels kept grinding to a halt over the years. He should probably get up to greasing those moving parts soon. Right, Steve? Yeah! And finally, there's the process of galvanization. If an easily corrodable metal such as iron is coated in a sacrificial coating of perhaps, let's say, zinc, then now the iron has essentially been painted in zinc. The zinc is the only surface exposed to the air and its moisture within, shielding the iron inside. Since zinc also oxidizes more readily than iron, it will want to complete any oxidation reaction first before the iron has a chance, hence the name sacrificial anode. This process is sometimes favorable to painting and greasing, as a thicker, more resilient shield of literal metal can be used, and it preserves the object's metallic nature. though upon galvanization, the zinc will corrode instead. It is okay as opposed to the flaky, dull coating of rust that iron corrodes into. Corroded zinc will turn into zinc oxide and eventually zinc carbonate, a nice, shiny outer layer that would adhere firmly to the metal it coats.
As the zombies start breaking down Steve's wooden door that he uses because he always found that his iron doors kept rusting and flaking off, Steve recalls one of his expeditions to the nearby village. There he remembers this one blacksmith who told him about his new galvanizing technique to keep swords nice and shiny. He also remembers he bought one of his swords for only 34 emeralds and stashed it in his junk chest. Steve quickly runs into his back room to pull out a new, still shiny, galvanized iron sword to fight the intruders. As the door comes crashing down and mobs flow into his home, Steve steels himself for an easy fight, wielding his sharpened blade and acute sense of the process of corrosion and corrosion prevention.